In this video, I'm going to show you how to graph this sine function that has an amplitude change, there's a reflection over the x-axis, there's a change in the period, and a vertical translation. But also I'm going to show you an alternative way of finding the values on the x-axis when you have a phase shift happening. But before I do anything else, I really would like to fix this garbage that's inside of the parentheses. Please don't look at this and think that the phase shift is going to be right 3 pi over 4. We have to pull that 3 outside. We have to factor it out. So real quick, if I do that, if I pull the 3 out, I'm going to have x minus, and it's going to turn out to be pi over 4. All right, I'm just dividing by 3 on both sides, and I can tell that that's going to turn out to be pi over 4. Now I can do that in more detail. Does anyone need me to explain further how I got the pi over 4 just now? Okay. People on the internet, there's actually a live class here. I know it sounds like this is just like I'm in the studio. Can you guys make some kind of noise so it just doesn't sound like I'm just, okay. Yeah, they're here. They're really quiet today for some reason. They're wonderful students, but they exist. They exist, internet. So I have negative 1/2 sine all of this, okay, plus 1. Now, to do my alternative method, this is what I do personally anytime there's a phase shift. This is what I like to do. I will just go ahead and mark off the x-axis evenly before I even know where the y-axis is. I'll worry about the y-axis later. So I'm just going to put a bunch of marks evenly all the way across my x-axis. Okay, this is a little bit of a different method than other teachers would probably do. So I'm a little weird, but it works for me. It might work for you. Okay, the first step of my alternative method is I start with the phase shift. That's the first thing I put on my number line is going to be the phase shift. So what is the phase shift? Looking at this equation, and class, please say something. What's the phase shift going to be? Pi over 4. They exist. They exist. Pi over 4. Which direction? Right. All right. So the phase shift is going to be pi over 4 to the right. Okay. So I know the y-axis will be over to the left somewhere. So I'm going to leave myself a little room over there. So I'm going to start with pi over 4, just right around here. Doesn't have to be exact which mark you pick. I'm just leaving room for the y-axis on the left. So first step is start with the phase shift. Now, on every problem we ever graph, every one of these marks is always a quarter of the period, 1/4 of the period. So I really would love to be able to simply add a quarter of the period over and over again. So of course I need to figure out what the period is so I can find a quarter of it. So time to find the period. Of course we know to find the period we do 2 pi divided by the b value. The b value is 3. So okay, I guess I'm done with the period. The period is just 2 pi over 3. Let's write that down. Okay, if the period is 2 pi over 3, that means each one of these marks is going to be a quarter of that. All right, I want to know what, I meant to put a quarter. I need to know what a quarter of the period is. So a quarter of the period, so 1/4 of 2 pi over 3. Okay, can you see that that's going to be, well, okay, at first I might write 2 pi over 12. But that reduces down to pi over 6. Okay. Now, I would really like to just add pi over 6 over and over again. Every one of these marks should be a quarter of the period away. So I should be able to just add pi over 6, add pi over 6, add pi over 6. Now, that would be a lot easier, though, if I had like denominators. So I'm just going to quickly convert both of these into like denominators so I can basically just count. What is the denominator that I could easily turn both of these numbers into? 12. They could both be made into 12s very easily. I could turn this into a 12 if I multiply these both by 3's. So that would be 3 pi over 12 would be right there. This could be made really back into a 12. I'm noticing it already was a 12 a minute ago, but let's pretend that that didn't happen. I would have to multiply this by 2's, and then I would have 2 pi over 12. Okay, so now I have like denominators. So I want to take my original phase shift and I want to add a quarter of a period over and over again. But I now have figured out that a quarter period is 2 pi over 12. So now I can just add 2 pi over 12 over and over and over again. Starting with 3 pi over 12. If I add 2 more, what am I going to have? They still exist. All right, 3 pi over 12. If I add 2 pi over 12, all right, because I'm adding a quarter of a period over and over again. I just made like denominators, that's all. If I add 2, that's going to make 5 pi over 12. All right, add 2 more, what do you get? 7 pi over 12. Add 2 more. 9 pi over 12. And the 9 pi over 12 is really why I'm making these red numbers down here, because I know some of them are going to have to be reduced. I need a total of 5 numbers, so I need 1 more. What's the next number going to be? 11 pi over 12. Okay. So I'm just going to reduce anything that needs reducing. So I've got 5 pi over 12 was fine. 7 pi over 12 can't be reduced. But 9 pi over 12, I need to reduce that. What does that become? 3 pi over 4. So I'm going to go ahead and write 3 pi over 4 because you must reduce, guys. And then I've got 11 pi over 12. Now I really need to see exactly where the y-axis is going to go. So I'm going to continue these numbers to the left. Just so I can see where the y-axis goes. So basically now I'm going to be subtracting 2 pi over 12 as I go to the left. So what's 3 pi over 12 minus 2 pi over 12? That's going to be pi over 12. Okay, I think I need to go 1 more. So that's 1 pi over 12 minus 2 pi over 12. What's that going to be? Negative pi over 12. All right, neither of those reduced, so I really could just write them down. So this is pi over 12, and this is negative pi over 12. Okay, I really just wrote these pink numbers down in case I needed to reduce. I didn't want them in my way. But these are really the numbers I'm looking at. These are the values on my x-axis. Now I can see exactly where the y-axis is going to go. I've got my negative, and then I've got a positive, so I know the y-axis needs to go in between those. So I'll just make sure to put my y-axis in between those two numbers. Okay, great. There's my y-axis. Okay, I'm just going to erase this work here. So if you used a different method, go ahead and check your answers now. These, your values on your x-axis should match these. Okay, let's go ahead and talk about, we've got this shift. The +1 on the end is going to give me a new midline. All right, y equals 1 is going to be my new midline. I'm looking ahead at my amplitude. Can you see that the amplitude is 1/2? All right, because of the a value. Did everyone put positive 1/2? No one put negative 1/2, did they? Amplitude is always positive. So I'm going to spread this out pretty far. So I'm going to put my 1 way up here because I know I'm going to have to go up 1/2 and down 1/2. So I really want to leave space for that. I don't want it to be squished tiny. So I'm going to put my 1 and I'll put a 2 equally high way up there. Go ahead and put a dotted line for your midline. Okay, that's mandatory. I also like to use a dotted line for my high values and my low values, for my amplitude. That's optional, but I think it makes your work look better, a little more accurate. So my amplitude is 1/2, so I need to go up half of a space and down half of a space. So these dotted lines are showing my amplitude, my highs and lows. Okay, you don't have to put these dotted lines, but I think it's helpful. Okay, hard part is over, guys. I am looking at these 5 values that I got with my whole counting technique. These 5 blue numbers, that's where I'm going to put my 5 dots right now. They're already shifted. I don't need to shift them again. This is a sine function, but it's got the negative. All right? We know that a sine function starts off at the midline, so I'm just going to go ahead and put my first dot at that first blue number on the midline. But because it's a negative a value, I'm going to go upside down. So I'm going to go down to the low point at the next blue number, back to the midline at the next blue number, and then up to the high value, and then back down to the midline at the last blue number. And that's it. Okay, this is what your graph should have looked like. All right, I hope that was helpful. I'll see you on the next video.